Welcome, class. Today we're going to talk about potential energy and the two different types of potential energy that we're going to be looking at. Now, according to the lecture, we had two different types: gravitational potential energy and a potential energy with a spring. Now, M is mass in kilograms. G is gravitational constant, acceleration meters per second squared, and height is meters. All right, so those are the units. And with this case, this is a constant. This is the spring constant. X is the distance as the spring, and we're going to show you what we mean in the next slide. So with gravitational, say a cliff. This is the ocean. And we got, say, a metal weight up here. This is the mass. The distance is what it travels from the mass to the ocean. This is distance. And of course, G is the gravitational acceleration, which is 9.81. So that's our constant. So potential energy is mass times distance times gravitational constant. Now with the spring, our potential energy, if we have a spring and it does nothing, it looks like this. This is a bad spring, I know. But if we pull it up a distance, we're actually giving it potential energy. So we have an actual potential energy with this. And if we press it down, we also have potential energy. So the potential energy is equal to Kx squared. This is the constant, and X is going to be the amount of energy that we pull or push. So the change in the distance. And that's how we get the potential energy. Now with the equation, we're going to look at how to solve these problems. Here's an example that we're looking at. A highway guardrail designed so it could be destroyed as much as 5 centimeters when struck by an automobile. We need this in meters, so we're going to have to change this. What's the minimum force constant if it was to withstand the impact of a car with this amount of energy? That's going to be interesting. Now, which equation to use? Folks, you got two different types of equation. If this says nothing about height, absolutely nothing about height, you use the spring. So this is actually going to use the spring constant, so potential energy. If we look at the equation, it's going to be this guy, 0.5 kx squared. So potential energy, PE, is going to equal 0.5 kx squared. We're looking for this. So X is going to be 5 centimeters, which is going to be 0.05 meters. And then the energy, I've got to look up here, 1.09 times 10 to the 4th. So, simple, we're looking for this. So divide both sides by x squared and 0.5. So PE divided by 0.5 times x squared is equal to K. This is our force constant we're looking for. So 1.09 times 10 to the 4th divided by 0.05. And that's going to be 0.05, and then we'll take that as squared, and that's equal to our force constant. So let's go ahead and solve. With our calculator out, it's 1.09 raised to the 4th divided by the quantity, 0.5 times 0.05, and I'm going to square that. And it's going to be, come on, pen. Whoops. 72 times 10 to the 6th. And that's going to, the constant is going to be joules per meter squared. And that's the force constant. That's the spring constant for this. So ladies and gentlemen, that is how you answer these type of problems. Again, if you have any questions, please give me see me during Scott time or after school.